Today I'm going to be looking at the design for the lower control arms and how all of this suspension geometry is going to start working together. I've got this mocked up like I had before. I've already noticed that I seem to be really wide of where I was targeting, like almost 2 inches wide. And we're gonna have to look at that because right now, like if I kind of like hold things in place and turn, it seems like this is quite a bit of steering angle before I'm getting to the sway bar. And I thought that that was going to be something that was really tight before. And it's kind of hard to check any of this stuff without a lower control arm in there because everything kind of wiggles and rolls back and forth and all that. I don't want to go building a lower control arm yet because if we're able to pull this wheel back in and tuck it some, I would like to, because it just means less body work later with a huge flare or whatever I'm going to end up doing on the outside of the car. I'm not really concerned about it. I know this will be wider than the original body. I just don't want to end up being, you know, way wider than I need to be because it'll just make that more difficult, and that's not going to be conducive to doing anything with autocross on a big road course. Not that big a deal. But again, we're going to want to be able to build a car that can do a little bit of both, so it is important to try and make sure that we don't end up being super wide, because in an autocross setting that just means during the slalom you have to turn that much more than a narrower car does. I'm stealing my Watts Link stuff to help mock up the lower control arm, and if you didn't know it, this is a fun little fact here. Standard thread in their jam nuts, smooth all the way around. The left-handed ones have this little hash mark in the nut. And on the sweadge tubes, at least the ones I have laying around, the little knurling to grip on, that's the left-handed thread side, and the right-handed thread side, there's nothing, it's just smooth. This is far from a solid mock-up. It still wiggles around quite a bit, but it's given me a pretty good idea of what needs to happen here. Mainly, we've established location of where that lower ball joint needs to go. I've also been able to look at the angle of these arms. They're not in the position the actual control arm is going to be in, but based on the amount of compression travel I'm expecting, which is about 3 inches, and from the pivot point to the frame here, we've got well over 1 inch, we're not going to bottom out using a straight piece of tube for the front section of the lower control arm, which is great because that thing makes it easier to fabricate. We also know that with the laser establishing center line, and over here's where the mount's going to be, that the ball joint is quite a bit forward of the center line of the mount. So I'm either going to need to angle the bar or put a bend in it if I wanted to make that tube be straight and solid and match up, because otherwise it's going to be more than 50% off the side of that ball joint cup. Option number 2, since this one is in the mounted location and it would only be moving slightly over at an angle, I like a lot better, because then I can use a straight piece of tube there and get a nice solid mount, and then the one that's on the front side will tee into that and have a gusset plate, and that'll be a lot easier to fabricate. I just need to be careful about how much steering angle I can get out of this tire before it hits, although this is on the outside of the cup, so that's actually going to angle in quite a bit. This would be a better representation of what we'd have. You can see we gain a little bit of angle, and that's going to the outside of the ball joint. If I swing it across and try to go to the inside of the ball joint, now we have quite a bit more. We don't have to worry about over here on the frame side mount. It'll easily take that angle. We can have a straight piece over here and gain quite a bit of clearance right around where a little bit my fingers and thumb are at in that area, because that's where the wheel is going to come over and get close. I also have the lower positioned where we have 3 1/4 degrees of camber on the top of the tire here. I would not be running that much, so I want to put more camber in during this mock-up so that when I add shims to the upper control arm, we'll actually be reducing it so that we can end up somewhere between 2 and 3. This is a good representation of what's going on with the front lower. This bar representing the mount surface in a straight line, square to the chassis. This 1-inch square tube is to make the offset as far as where this ball joint lines up, because it actually is exactly 1 inch from that interface to where it's out at the tire. And the center line of the mount is going to be an 1/8 inch that way. So what we'd end up with is definitely something like this if we try to make a straight tube out of that front. Which is why, if this comes in like this, it's a little more appealing to do the straight tube off of that rear mount. And then this one can cope in a straight line, and you can add some gusset to strengthen it up around the backside too. Another thing that becomes obvious with this mock-up is that we can put that ball joint cup flat and level to our mounts. It's not going to go through enough travel on anything to get close to maxing out that ball joint, so rather than worry about trying to get a specific angle, we can just lay it flat on the table for tacking up. Now, even though I know that we could mount ball joint cup flat to the lower control arm bars, we can always try to make that a little bit better. So right now, if I put my angle gauge on these bars, I get between 3.5 and 5 degrees. I also know that my kingpin angle on the spindle is 7. So really, we're looking at 10 to 12 degrees of difference because the cup is angled this way with the spindle, plus our camber, so it's at 10 degrees already right now. And then we've got a 3 to 5 degrees the opposite direction. Well, we can average that out by just shimming up the outside corner of this ball joint cup when we're tacking things up. And a little bit of math says that that is 7/16 of an inch that we could stack underneath the outside edge to tip it at 10 degrees. With the wheel turned here in mock-up, doing my best to keep that lower ball joint in the position it's supposed to be. We're ending up with 2 5/8 clearance here. I know that this little, 1/8 inch or so in from the outside is where that sway bar arm is going to sit. So right now we're at about 2 1/4 with that. So we'd still have, 3/8 or so of clearance to the arm, and this looks like a pretty heavy steer angle. It's definitely better steering than the current car has by a long shot. Not exactly sure what angle that is, but it's quite a bit. Now, if we swing it back around to the other side, we're hitting down here, and that was an obvious case of what was going to happen. And this is where, if I move that bar to aim at the inside edge, we're going to have another inch of clearance or so. It's quite a bit. It's at least the full thickness of that tube. Yeah, an inch at least. If with this angled in a lot more, and we're currently at 4 1/4 inches, so we still have, 1 inch, 1.5 almost, not quite, or a little over 1.5 inches to come in, but an inch here is going to add up some more here because of the arc distance. These weld-on joints are what I'm planning to use for the front. However, in the name of doing a mock-up control arm before I get serious and use up those, I'm going to cannibalize one of these sweadge tubes. I'll need 2 for the rear suspension lowers. However, we're going to change that pull bar upper so I can do away with one of these. It's actually just long enough. I should be able to cut it and only be a little bit of trimming in the middle to make both bars. I can jig up this first bar in a couple of ways and get the 10-degree cup angle. One would be tipping the ball joint cup just like that. This is the 7/16 thick nut. It's actually a 1/2 inch 13. And that makes the right angle on this cup. The other option is, my plan is to weld this bolt to the table to hold it in place, and then I can set center to center. However, if I put this up at 2 3/4, that makes the same 10-degree angle. And then the ball joint cup can sit nice and flat on the table. It'll be way easier to find center to center distance that way. And then I'm not too picky about it being totally accurate because we do have the adjustability on the end. Now with the first section tacked up, I'm going to take it over here to the frame and put it on the frame and get it mocked up in this position again so that I know I have this arm locked in place before I make the front one, and that is just to make sure that everything's going to fit. I really should be able to go center to center over here, and then knowing where it's going to line up on the ball to do that as well. However, there's lots of room for error there, and if I just mock it up in place, I know it will fit. Already we can see that ball joint angle is working out quite well. So let's get the front section made. I marked center line here on this tube. I squared it to the frame because if I get too far over here, I'm hitting the support. Although it would be nice to angle that over. I don't want to grind away my gusset down here on the bottom either. So I'd rather set this up square. I'll cope it into this tube, get it tacked up, and then as far as reinforcing around the ball joint area, that'll be a lot bigger of a job with a gusset. Not quite perfect here. Ended up with a little slight angle of the backs. I trimmed it too short because I didn't have the wheel in the right place, but that's why this is a mock-up control arm. But we are rigid now, so we're not flopping all over the place like we were before. We can swing the tire. Oh, we're actually bottoming out on the upper control arm right now and not the lower, so that's a good sign that the lower is plenty enough out of the way. when we get to the sway bar, we'll have plenty of room there. So let's get this evened out and see how much steering radius or steering angle we actually have. Let's say that's almost 5 inches that we can turn with. And if we trust my notes in the math, having 5 inches of steer clearance should be around 28.5 degrees, which to visualize that, it's quite a bit. I actually don't think that's going to be too bad at all. Oh, and I did mention earlier in the video that I thought I ended up too wide. I'm not sure what I was looking at or what I think I wasn't factoring in the fact of the tire width offset, and I was kind of comparing to the rear end without any wheels and tires on it, but we're actually exactly where I was targeting. I mean, maybe within 1/8 of an inch as far as what total width is going to be on this. So everything did work out the way I did the math. I just was getting a little mixed up in my head, but this should be pretty sweet. This proves out that I can make these lower control arms nice and simple with some straight pieces. It will just come down to making sure I have enough strength. Like I said, I ended up cutting this one a little bit short, so it's angled back slightly. It's probably going to contact more up here. I mean, basically where I showed the math earlier on the other table. So this bar can be nice and straight, tying in here, and then I'll probably have some kind of gusset that wraps at least 50% of the way around, maybe some more, maybe come out to the back here and just triangulate all of this in. You know, if I have a piece that gussets like that and another one off of here and then a little bit in between these two, this should be a more than strong enough control arm. I could even cut a third piece of tube that bridges over here instead of really box all that in. The other thing I'm going to have to factor in is where the coil over mount is going to go. So I'm probably going to look at some of that before I get too far along in actually trying to build these control arms. I've got spacer blocks underneath the tire, so this would be maximum compression. I still have plenty of room for my lower control arm up to the frame, so there'll be no notching there. That's really nice to see. Saves time and effort. This is also gaining 4.1 degrees of camber at the tire during this swing. Meanwhile, that same 3 inches of compression on one side factoring across the width of the body, that's only 2.3. So we're gaining almost 2 degrees more of camber compared to body roll. And body roll only being 2.3, we're almost at a 2-to-1 ratio in gain. It's a little less, it's probably like 1.9 or something like that. I really don't care about the accuracy. I just know that I was targeting about an extra 3 or 4 degrees for say 6 degrees of body roll. We're like half that, so we're right in the window that I was shooting for. And I'm not basing this window off of anything other than my experience with the other car, and in the fact that when I made the camber gain a little quicker than what the body roll was, I almost doubled my tire life along with fixing bump steer at the same time with that. So I want to be in the same window as far as starting. That's totally tunable with the adjustments that we have in this upper control arm mount. We can either increase or decrease the camber gain. We can also change our caster, which changes the camber in a turn a little bit. Small percentages, but it's just a little bit. Big thing is that I know we're in a good spot to start. Also, with a quick glance at the coil over here, we should have no problem mounting this thing pretty far out to have a good motion ratio. These coilovers are sized where they can be 1-to-1, so I want to try to get as close as possible on that. I should be able to put this coilover mount pretty far out. If this is maximum compression, I can also put this mount out far enough away from the frame here where we can have it pretty close to vertical. It won't be perfect, but the closer we can have it vertical, the more effective it is. What that does, however, do is pretty much forces us, we need to hang the sway bar or torsion bar arm underneath,
which is just fine by me because I'd rather have it a little farther out. We'll have to put a bend in those arms to kick them out. But if I'm putting it underneath here, I can make this entire area right here that's going to be taking all the load be very strong and nice and close to the ball joint. So you can see this isn't quite flat, and that was just a matter of a little bit of orientation difference when I tacked it on there. So I'm going to cut these two tacks, lay that ball joint down flat, and then re-tack this in position, at which point I need to turn the rod ends here because I need to make brackets to make a jig where it holds a horizontal piece in, and I need it to basically hold these outer barrel parts in place. I know that this needs to be squared up, facing straight out from what would be the frame, nice and square. This one will be angled. I'll have to double check the angle because I know it's not perfect in line with the arm. So there'll be just a little bit of double checking there, but once I can get those made, I'm gonna move this stuff to the center of the table, then I can flip it, and then I can make lefts and rights. Well, I still lost my spot. Dang it. Shoot. Well, so much for that. I'll have to start over again. Oh, jeez. Shit, that went deep. On that nasty little sucker there. Just trying to pull it loose off of here, and it came up, and my hand was right there, and whoo, sliced all the way across. Ouch. Luckily, not a ton of blood gushing out of it, so I didn't hit anything serious, so we'll just tape it up. Anyway. Using this bar as the setting for the ball joint. So we can set this one, we can't go off of this because it was angled. This is where if we'd have made it everything, you know, dead flat and not tried to correct that ball joint angle, it would be a lot easier because everything would be sitting flat. It would have just been whoop, flip it and bump it up and it's good to go, but it's not. So how I'm setting this is we're just gonna be center to center distance along here, so it'll bump up against, and then center to center of the pivot needs to be the same. That way we can mirror it. For the one in the back though, we'll have to make another standoff spot. That's why I tacked these here, as long as I can still rotate it. But I might not be able to. So what I'm going to have to do here is this is holding this from wiggling around too much. We'll have to see what the distance is here. Actually, I probably should have marked it and then, you know, just flip it back and forth kind of a thing. So as long as I get this measurement the same on this side, I can really disregard this altogether and make that happen. I was hoping this was still going to rotate, but it's not. So yeah, I'm gonna have to rethink that one a little bit, but get the other side set, get this ball joint cup tacked down to the table where it needs to go, and then basically I'll have a mirrorable setup for both arms. Now I'm ready to start making tubes. I've got my joints fixed, put them spacers in there just to hold it on center, and I had to machine the inside part out of steel. This is so that I'm able to weld these in the jig and not have a problem there, whereas the bushing material that goes in there is some kind of Delrin or plastic. It's something that will melt anyway. So I didn't want to risk damaging that stuff at all by putting them in there to weld it and hold the bolt centers. Ball joint cups just tacked to the table. So we can make this control arm, and then we just restock this one, add one here, and then we can build that control arm. And then there'll be mirror images of each other. There to there. It'll heal up.